live. So welcome to the Energy 2020 yearly update session at Cable Tech Expo. What an exciting day. With all the highlights and views to the future, and in particular technology, the common enabler will be the network, and fueling that network, of course, power. Let's take the next 90 minutes and uncover what the industry is up to regarding energy. I'm Derek DiGiacomo. I'll be your host for the next 90 minutes. I've been in the industry for 22 years, and I'm the Senior Director of Energy Management Programs and Business Continuity for SCTE. Our agenda for this afternoon is the SCTE. I'll have an overview for about 5 minutes. Then we'll dive into our exciting MSO energy stories, and then we'll wind up the session with some discussion from our Gridmetrics team. I'm really excited and appreciative of you joining us this late in the day, and stay tuned. We have some really exciting things to cover. So never before have we seen such rapid ramp up of demand for based off of our customers' use since the beginning of COVID in March of 2020. And as NCTA reported, the industry performed remarkably well. And guess what? The amazing power management and consumption remain relatively flat regarding power. We're seeing network transformations, and Ryan, thanks for this image. I borrowed it from one of our prior plenaries. That there's lots of options at our disposal for building out new network. It's traditionally HFC, we have remote PHY, and fiber to the home. And one thing in common is that power is no longer an afterthought, and we're seeing it largely be a strategic asset in making new decisions regarding and recognizing that there could be a shift in where power is taking place within our network. And we're seeing trends like a lot more cloud adoption. So luckily, we have a great foundation of resources to help ensure network power optimization is being embraced from day one of new build-outs. As I said, we have a solid foundation around a lot of the good work that our subcommittee has done, as we are part of the ANSI accredited standards work. Standards body is SCTE. Many of these were seeds that were placed, developed as solid go-tos for transformation of networks. So all of these documents are available for free at the SCTE website. You can leverage them to their fullest extent. However, there's still more work to be done in the standards world. We have met the initial Energy 2020 program goals, and now it's time to keep the ball rolling. So where are we headed? What's going on with this program? So as you may have noticed, we do have a refreshed brand, and Energy 2020 is turning our sights to the future. Our team is continuing our mission to innovate and educate our industry on ways to stay reliable and responsible. We're taking the program's success in energy management standards and best practices and setting our sights on what's next. Now that we've met our initial goals, as I mentioned, SCT is continuing to lead the way towards sustainability, excellence, and power, reliability, availability, and performance. And again, as I mentioned, there's still more work to be done. We're setting bigger objectives, developing better practices, and sharing best-of-breed training to ensure our vision of responsible and dependable energy management is realized and maintained, always with the cable subscribers in mind. We're setting standards for today and enabling the vision for tomorrow. So really excited on where we're going. Speaking of where we're going and where we've been, we published a new page on our website. You can visit the SCTE.org website, and we've captured a number of milestones that have taken place over the first phase of the Energy 2020 program. So just browse through our website, SCTE.org, and key in Energy Milestones on that search function, and you'll be able to see and page through all of the history that has taken place over the course of the years. We've also linked to a couple of assets like the Gridmetrics team and the Cable Labs Energy blog for you to read at your leisure. When we began in 2014, we did a lot of research regarding what does our energy footprint look like? Well, here was the original power pyramid that we published back in around 2015. The initial analysis, we had a limited amount of data, so we did do a lot of extrapolation and estimation on where power was consumed. That was a good representation of what the footprint looks like. So let's move the needle a little bit forward to today. Today, you see the updated power footprint. It's amazing how much more data is available to our operators, and this enables a more accurate picture. Again, to note, based on researching the initial goals that we saw, a relative flattening of power usage during the exponential growth of traffic. So hats off to the team. It's a testimony to the documents that we published to date. So continue to leverage those, and we'll continue to build more of the documents that are needed to move that needle forward. The future is bright, and there is more work to be done. So let me welcome some of our key cable partners and our energy program to set that stage. So we have 4 excellent presentations. Our Cox team with Chris Waters and Mike Glazier will be kicking things off, followed by Comcast Ryan Capone. Then we'll hand things over to Todd Musat with Shaw. And then rounding things out will be Sam Kohler with Liberty Global. So without further delay, I'm going to go on mute. I'm going to hand the controls over to Chris. And Mike, you can take care of the intros for Team Cox. Thank you so much.
Thanks, Derek. I'm Mike Glazier with Cox Communications. I'm a critical facilities engineer and have been involved in SCTE and Energy 2020 for a number of years now. And I've done this a time or two as far as an update, but I thought I would turn the reins over this time to Chris Waters, Director of Sustainability, and she's going to give an idea of the roadmap and where we've come and where we're going, and all about sustainability, circularity, and the great things we're doing here at Cox Conserves. Over to you, Chris.
All right. Thanks, Mike. So as Mike mentioned, I have the honor of leading Cox Communications sustainability programs. I don't at all do that alone. So there's entire teams sitting behind me and that are, experts in the engineering space. What I'm going to try to do today is just give you a high level overview of what we're doing, and how we're planning to get to our big, audacious goals. We're lucky at Cox Communications that we get to think a little bit more multi-generationally. We are a 4th-generation family-run business under Cox Enterprises, and sustainability is really in our DNA. Cox Conserves was founded in 2007 by Jim Kennedy, still our chairman, but then our CEO and chairman on the Cox Enterprises side. And they've got 3 big audacious goals, 2 of which got a lot more aggressive in the last year. So we're about to hit zero waste to landfill. The goal for that is 2024. That's a terrifying goal for a non-manufacturing company. And I think we've made some incredible progress through those circularity initiatives that you mentioned, Mike. And then our original target for carbon and water neutrality was 2044. But in 2020, we actually took the step to go through an extensive strategic planning process and brought that into 2034, really to meet the needs of our customers and the communities that we serve. In progress and on the horizon for us, we also are diving in on a sustainable supply chain goal so that we can start thinking about the impacts that live outside of our 4 walls and our plant. And just to talk a bit about, let's see if I can get back. And technology works today. To talk a bit about the scope of those carbon and water neutral goals, I do want to talk about specifically kind of the greenhouse gas protocols that we use to define those goals. We are targeting those carbon and water neutral goals against our scope 1, which is our direct emissions, or the fuel we burn ourselves, the actual emissions that we put into the air ourselves, as well as our scope 2 indirect, which is really the impact of the energy that we consume. Much larger than both of those is scope 3, and that's really tying into that sustainable supply chain goal that's on the horizon for us. That is effectively the environmental impact of every dollar we make and every dollar we spend. So all of the downstream impacts that occur in customer homes and in waste processing, and then upstream impacts that occur with our suppliers. But we're putting our money where our mouth is, and we've got a pretty detailed plan and strategy for how we're going to get to these carbon and water neutral goals, as well as our zero waste to landfill goal, which is a much shorter horizon. Over the years, we're going to invest almost $400 million in order to get to the finish line. And we've got strategies that go alongside there. Our carbon strategy is a bit diversified, but what you're going to find is we've got a lot of our focus on market supplied and Cox-owned renewables. We're continuing our efforts on the energy conservation space across the business, not just within Cox Communications, but also within our Cox Automotive and our new clean tech enterprises. But we also recognize that there's a portion of that we're going to have to look at restoration for, and that means looking at carbon capture technologies, and other partnerships we can use to make a difference to offset that last little inch of getting to carbon neutral. On the waterfront, conservation is a bigger piece of the pie. We really have to get a larger percentage of that in through conservation, but there's only so much you can do with water because the water cycle kind of by its nature is renewable. What we recognize though through consumer insight studies is that clean, safe drinking water matters to our customers quite a bit. So we're looking for meaningful external partnerships, and we've already engaged in several there where we can actually improve water supply and achieve that water neutrality goal through some of those external partnerships as well. And then waste, I'm happy to say on the Cox Communications side, we are literally at the finish line. So we are 89% toward a 90% target that the kind of industry recognizes as zero waste to landfill. We're very excited about that. And that's been a ton of heavy lifting and deep business integration. At the enterprise level, they do believe that there's a portion they may have to look at for external partnerships in order to push us farther than the 90% and start looking at what is truly resilient communities look like, and how do we use what we know to share with others. But Cox Communications has done a fabulous job on this zero waste to landfill goal. In the carbon space and the energy space, of course, given the topic of this meeting, we recognize that a bigger and bigger portion of what we're doing is going to be defined by market supplied renewables. So just as a point of reference, 2% of our incoming supply was renewable in 2019. This year, we're up to 19% between Cox-owned renewables and market-supplied renewables. And by 2023, we expect that number to be a whopping 50%. So we're looking at renewables as a really important part of how we're solving kind of the carbon challenges of our industry. And as you can see, I mean, that growth curve is pretty significant year over year. We've got a lot of in-house projects in play. We'll talk about those in a bit. But we're also looking to new technologies and innovation to solve for some of our energy supply in new ways. So hydrogen, integrated hydrogen technology is one we're looking at deeply, both on the fleet side as well as the backup power side. But battery energy storage, as you guys know probably better than most, has really kind of come down in cost, and we've got some great opportunities with that battery energy storage to improve our dependence on renewables, because we can use batteries to actually make it more dependable. And then, like many, we're looking at distributed energy distribution or microgrids. Where can we place power and add value, not only to ourselves, but potentially to other utilities in the process? Some of our conservation projects that we've done in the last year, you can see have actual functional benefits. So you look at that before and after. That's a parking lot in our San Diego market, and the before and after are night and day, literally. But with that, we also saved 46 tons of carbon a year. So small changes, again, at great scale, can make a big difference. On the renewable side, our Phoenix, our kind of largest market, our Phoenix headquarters actually just had their solar installed. We're hoping to interconnect that at the end of the month. And we've got some great savings there. That's just an example of several projects we've got going across the country. And then when we look at zero waste to landfill, when we think about that scope 3 impact, the environmental and carbon impact of our waste processing actually has a pretty huge impact on our scope 3. And so this achieving zero waste to landfill is a great first step to that, because there's also a source reduction element that can also affect kind of the upstream portion of scope 3. We've gotten through, a lot of extremely exciting milestones there. And much of that was based on just blocking and tackling, integrating deeply with the business. People dumpster diving. We do this and it happens. And then, really looking at how do we harvest some of these amazing innovation engines that we have within our own employee base. Our employees know better than anybody where the waste lives in the business. And so we found some great ways to tap into that and really leverage it for taking our zero waste efforts to the next level. And then when we start thinking about supplier sustainability and kind of related to that waste side, how do you look upstream and how you can reduce your impact? What we found when we did a basic impact assessment was that most of our impact lives outside of our four walls, the vast majority. In fact, waste, because our waste impact is so low, is 60 times the impact we have in our four walls. Water is also 60 times. And even carbon, with our energy intensive business, is still 6 times the impact that we have within our own operations. We break that out. We start looking at upstream supplier side impacts and downstream customer CPE side impacts. We've got some really big things that we need to do to partner with our suppliers to improve the overall environmental impact of the business. And so this year, we're really building in some foundational elements that'll allow us to measure and set goals in 2022 and beyond that will drive improvements in this space and really great partnerships with our suppliers to build a better world for the next generation. Just as an example of some of the projects that we're working on in this space, coaxial cable. You guys know I am like the coaxial cable queen. I will talk about this to my dying day. But we're really looking in that coaxial cable space. How do we go from a linear to a circular economy on that? So a circular supply chain where that waste product actually goes into a new product as a supply material. So looking at that, we currently generate about 30 tons per month. Previously, that was actually closer to 50 tons per month prior to a great partnership that we engaged with our coaxial cable RG6 supplier, where we were actually able to start using reusable reels to reduce the amount of new coax that was landing in the recycling bin. Next steps, we're working with an amazing organization named Ubuntu, who is helping us to source end-to-end upcycling solutions to help us make sure that 90% of the coax that we are already spending money to recycle is actually going into new products. So it's really those end-to-end solutions that we are diving deep on, and similar solutions exist across our entire product spectrum. That is me. I will turn it over to Ryan.
Very good. Thanks, Chris, and perfect segue for my update, which is going to focus on a lot of the same.
Ryan, before you jump in, let me just mention to Mike and Chris, as we don't have a lot of time for roundtable discussions with this team, there is some chatter going on the public side of Q&A. So again, if you want to open a public browser, jump in there and continue your conversation, go for it. It's exciting. Thanks, Ryan. Go ahead.
Perfect. All right, hello everyone. My name is Ryan Capone. I'm the VP of Critical Infrastructure and Energy Engineering at Comcast, and I'm here to share some exciting updates and some news on our end around similar efforts as to what Chris just mentioned for Comcast. So we solidified our commitment earlier this year to a 2035 carbon neutrality goal around our Scope 1 and Scope 2 emissions, and wanted to spend a second on the why. I think what this really is a solidification of the work that we've already started, has been ingrained in our culture at Comcast. We've been involved in the Energy 2020 program since the beginning, and really puts a time-bound goal on it internally, which triggers some additional motivation, some organizational change, and has positioned us well for the future. It's also about doing the right thing. Obviously, we're looking at the environment itself and the timelines laid out in the Paris Climate Accord, and then the last piece, the business element of it. There's attention and there's pressure for major corporations, and I'm glad to be a part of this forum as well as other peer companies and across the MSOs around similar time-bound goals for carbon neutrality. So similar to Chris's slide, Scope 1 and Scope 2 and Scope 3, I don't have to do too much education there, but Scope 1 is our directly emitted exhaust and emitted emissions. Scope 2 is our purchased electricity, and those two scopes are where we're really placing our focus first, and I have some slides kind of baselining where we're at today. That's not to exclude Scope 3 and the work we do there, but it is in the next step sort of phase. So important to understand the baseline of where we are at today at Comcast. We have a footprint of 2.2 million metric tons of CO2. This is data straight out of our carbon reporting that we did earlier in the year. You can see on the left-hand chart that ticked down from 2019. Large driver there was COVID-related work from home activities, so a downtick in some of our administrative building usage. But then on the right-hand side, you can see just where the majority of our scope 1 and scope 2 comes from. Over just about 75% of our total emissions come from purchased electricity. This is all of Comcast, so it includes NBC and the parks, as well as the cable operations, making up the larger majority of it. So I wanted to share a little bit about our approach and how we're thinking about energy management now and into the future. We're going to spend, I'm going to bring everyone through sort of our LRP and budget and forecasting. What we're doing is looking at our energy consumption over time so that we understand where we're going to be growing, where we're going to be shrinking, and what decision point triggers do we have to make at what times to either in new technology investment or in potentially offsetting activities like purchasing renewables. We've got a planning and design pillar that looks at what we're doing to control energy and what how we deploy new equipment, looking at things like SCTE 213 metric, total productivity of platforms. When we're in that planning and design process and really engineering and bringing energy into the veins of our business, and to use an analogy, not being a bolt-on afterthought. And then we get into execution and deployment. That'll be around capital execution, specific capital dollars we spend into platforms that are more efficient or energy efficiency plays like critical infrastructure efficiencies and things like this. We are working toward an energy management system where we're going to have a holistic understanding of our energy consumption and the cause and reaction of the things that we do in the above work streams. And then not to lose track of maintenance and management. So what can we do to make sure our existing operations are most energy and carbon neutral so that we can reduce our energy consumption. And then the last piece is working with our utility providers and suppliers. And this gets into everything that we can do to shave down our consumption and maximize our efficiency. We still have a procurement play to make on how we source our energy for the rest of it. So here's where we're at in terms of our LRP. I brought back the pyramid. Comcast is certainly within these ranges here, outside plant making up the majority of our consumption. But we ran a lot of about 5-year out looks on where we see growth. And that's the reality of it. If we sit still, we're going to grow in terms of energy consumption. So it's a call to arms. Like I mentioned earlier, the only grouping that we see a downtick in over time here is our non-technical use, non-technical facilities, meaning office spaces. And I'm broadcasting here from my home still. We're still very much in a work from home environment. We expect that to change over time, but our overall usage of non-technical facilities most likely will be less than it was pre-COVID. Data center space, not extraordinary amount of growth there. So relatively flat, kind of a tech refresh cycle go through recently, some storage and cloud applications there, but a lot of puts and takes that is netting out to a small uptick. Where we're seeing the largest amount of growth is in our critical facilities or our hub sites and head ends infrastructure. And what that is I've got a couple of notes down below. We looked at a number of items in the network. Right now, we're in the midst of virtualizing our CMTS platform at Comcast. So while we're doing that, we actually have some overlap of network platform situation where we got to turn the new thing on before we can turn the old thing off. I'm sure all the other operators out there know that drill. So we have a bubble that we're going to work through in the short term. Then we have our normal capacity growth based on existing CMTS and virtual CMTS, just our typical capacity growth on the network side that drives increases in platform widgets. We're looking at tech refresh cycles. So every X amount of years, how often is platform X, Y, and Z going to refresh? because we have that same bubble to care for, as well as an opportunity in those cases to make sure the new platform going in is much more efficient in terms of its productivity and energy usage. We're looking at CI efficiency. So our about average across the nation in this space is about 1.7. We think we can do better. We are working on a couple of different things I'll be talking about on the next slide to continue to improve that. And then we have our commercial customer growth, which has been one of the fastest growing parts of the business. And then in our outside plant, we're seeing a modest uptick, and it's largely around, I call it plant extension activities, whether it's rural broadband or true plant extensions into new neighborhoods and serving areas following construction activities. We are also looking at a mid-split transition, which we're going to do over the next few years around replacing amplifiers in the plant. I'm going to get into some of the opportunities that we're looking at here in the next slide. So bringing those opportunities to light, what are we going to be doing about it? And there's already a lot of work that's been done, but like I said, we got to crank it up a notch. So we're right now in the very much brainstorm phase. We got several trials underway around outside plant efforts. So one of the things we're looking at is right sizing power supplies, or as we like to say, getting out of the inefficient zone of the ferro transformer. There are a lot of power supplies in our HFC network, and unfortunately, when we're in the lower half or so of a large like 15 or 18 amp ferro, we are operating in a pretty inefficient zone of that ferro transformer. So we're looking at either right sizing power supply for the application or redesigning. So looking at case-by-case ROI on plant redesigns. And a lot of this is coming up now. I mentioned earlier, we're kind of moving to mid-split. When you look at, these very numerous items in the plant, it becomes a little bit overwhelming. So it's very hard to say, hey, we're going to go do and touch all that stuff just based on the energy play. But when we get back to, the thought of, energy is in our veins, when we go touch, we should be looking at the efficiency of these items. And that's exactly this last bullet point for outside plant, is just looking at the line extender's power pack efficiency. It's been taken for granted. It's a very low wattage device, but at the end of the day, it operates on average around 57%. So for every one of those things, we're losing 15 watts to the heat. You multiply that by the millions that we have out there, and that starts adding up to be a lot. So when we do the touching, we want to make sure we're putting in the best possible efficiency, and a lot of that gets into financial analysis, capital cost over operating cost over time. For the inside plant piece, very much like the same thought, we're looking at the platform productivity using SCTE 213 metric to measure the IT productivity and the CI productivity and the overall output of the facility in terms of watts. But we're really driving that down to equipment platform selections too. So we are looking at, when we go through our technology cycles, when we get to next generation equipment, how can we squeeze every single bit of efficiency out of every watt to service to our customer, or in terms of terabytes or bits provided. Same way, we're using SCTE 186 to look at the energy efficiency standards of the platform before the purchase, as well as other, I call it staple environmental items. Let's make sure things flow from the front of the equipment to the back of the equipment. We're looking at hot standby power supplies. This has kind of been an interesting topic recently. Dell has a platform where you can enable a hot standby mode that turns one of the power supplies basically into a kind of a hot standby state. It doesn't draw power. It puts the other power supply in a much better efficiency point in its efficiency curve. So we're doing a case study in the lab on that now, and that could be a nice little win, because that's basically a software setting that we can enable in the field if we're comfortable. Now we continue to look at maximizing our economization and passive cooling. Tom Hurley has done just a ton amount of lifting here internally at Comcast about setting, getting people comfortable And I think I was talking with Mike Glazer about this from Cox. That's the biggest part of it is debating or bringing data to the old adage that I need to drive down the cooling as cool as it can be so that I have more time to respond to a site. Same thing around standardized set points. There's a point there. And finally, we're looking at solar and storage, as well as larger alternate energy plays for the inside plant space, as well as our administrative spaces and whatnot. So that is all I had. Appreciate the opportunity to talk today, and I'll pass it on to the next presenter.
Thank you, Ryan. And let me, Todd, bring you to the stage and give you control. So stand by. And that should be coming your way.
Thanks, Derek. Hello, everyone. Again, my name is Todd Musett. I am the Director of Network Infrastructure and Standards at Shaw Communications. And what I'd like to do today is update you on Shaw's Energy 2020 strategy, our progress and our successes, and finally, what are our next steps looking into the future. Shaw has been a part of the Energy 2020 program since around 2 years after it started in 2017, where we learned and contributed towards building and sustainable and optimizing our energy consumption platforms. There. And during that time, we did introduce Shaw's energy strategy in our 4 pillars. First one being data collection, then performance metrics, projects, and operational sustainment. Under all of that would be industry and power utility collaboration and sharing. So we have been very successful. And what I'd like to do today is really focus on the first 2 pillars of data collection and performance metrics. Not to say that, that we still are working on projects and operational sustainment, but I think it's in these 2 pillars that we've shown that we've really kind of moved forward and are able to then really change our projection when it comes down to how we spend our OPEX and our CAPEX in projects, and then how we look to better our operational sustainment. So again, data collection is the monitoring, the audits, the capacity management we do, the analytic tools that we purchase or secure, the trending models that we look at, and then looking to see where there's a monetizing of some of that data that we're collecting. And then performance metrics is really establishing those KPIs, budget forecasting, our power utilization, and then, what is the effectiveness of that, our optimization and our energy optimization priorities. So, I'd like to start with, Ryan did before, with the legacy Energy 2020 pyramid. So, this was a very interesting kind of projection that when we looked at it, we really had to look at it at the point of view of our consumption, not through the lens of data collection, but actually through either estimates or through direct invoicing. So really at a different, maybe not so accurate kind of point of view of how much we spend rather than how much we consume. And that really kind of set the stage of really having that gap of where did we have really good analytics and data collection to actually tell us how much we're consuming as energy. So when we first looked at that profile, 53% and the HFC power supplies, 28% of our hub repeaters and pop sites, then 19% in data centers and core sites. And also at that time, we weren't really able to do a differentiation between critical sites and sites that are non-critical in the sense of our facilities and our offices, our warehouses. So really was a little bit of realized there's a little bit of shortcoming in the sense of where we were with truly our consumption. So moving today, and with that refresh model of an energy pyramid, we're very confident that the numbers that we present really are reflective of what we consume rather than what we spend. So we're able now, with the analytics we collect, to actually tell us in the outside plant network, how much the consumption level is. We're able to now break apart between the technical facilities and the non-technical facilities, and then really have an accurate kind of projection of what our actual consumption is. So thinking on the successes and what we've learned and what we've done with some of that pre-analysis, saying where our gaps were and then what our opportunities were, we really did focus on the telemetry that we actually have or could have, and then how to move forward. So I'm very happy to say that, and this is really a credit to all the groups that work on the teams that work with on this. 100% of our ATSs, UPSs, DC plants, and meters are online now and polling. 75% of our outside plant power supplies are online and polling now. And that just gets better and better as we do upgrades to older power supplies in the outside plant and getting more online. And then what we've really now moved towards is our HVAC systems, them being online and polling. So we started at 2 years ago, we had virtually none that were actually polling, to where we now have 15%. And with the lessons learned and that slow start and trying to navigate that space, we're very confident that we will complete all of our HVAC systems, which is around 700 or so units and polling points within 2 years. And then utilizing that analytics for monitoring and negotiate better rates with our utility providers has been very, very critical, because we can actually show real-time metrics and analytics and data to show of what our actual consumption is, rather than looking at just billing information. On the analytics side, we really have moved towards a centralized polling analytics system that both works for outside plant and for inside plant. So it used the same polling engine. And from that, we're able to then, with our DSIM tool, that create dashboards and those what-if scenario plannings that we can actually then kind of make projections and look forward. In HVAC efficiencies, we're in Canada, and a lot of our sites are in Alberta, which is a perfect space for free air cooling. So we've utilized a lot of that. And then also variable speed compressors and fans. But going back to controls, which is actually more telemetry, we're able to now, we had simple controls. Now we're able to have controls that are much more dynamic, that are able to give us much more information rather than just what the temperature is. We're able to now manipulate that and make changes, and then we can get into more expansion of that as we go forward. And then containment has been a very important thing. And I know SCTE 219 actually is up for a vote tomorrow, I think is the closing date. So really we've leveraged a lot of that information in that standard, which has really helped us really kind of maintain efficiencies with our HVAC systems. And then back to that sustainment and really concentrate on maintenance and getting the most out of our existing units by making sure our regular maintenance standards are withheld. Electric efficiencies, UPS switches, ESS mode, save about 50% power on lighter load units, and really investing like the Cox team showed on LED lighting systems. We too had, similar, results with really changing our LED systems when it comes down to parking and within buildings. And really, a really interesting thing that we've done that has really been successful is on our outside power plant, where we've seen a considerable amount of reduction in power by just rating and going towards cold weather batteries and replacing our existing batteries. That alone has, they're 21% cheaper that we found. They're able to reduce and not need a heat mat anymore, which has been an overall reduction around 45% in capital costs, but also energy consumption at around 570 kilowatt hours per year per power supply. And within Canada, that represents around 50% of our power supplies that have needed a heat mat. So very substantial type of move forward by just using what's available and newer technology in the sense of cold weather batteries. Next steps, looking forward, really that data roadmap is still not changing, it's evolving. It's like all data, you can be overwhelmed by just the amount of it. So it's really now learning how to best use the telemetry we're getting and what is our new directions on that data that we're collecting. Next is payload. Really, creating that space for the network teams to actually understand what their consumption levels are and how they can live within that space. Site design, it's really optimizing the new builds and renovations that we do to really bring in all those elements. We are going forward with PPAs and stuff as we evolve our GHG strategy within Shaw. Self-generation, we've already conducted a solar PV pilot, which we have very happy with the results. And now we're able to start expanding into newer sites, really on a on-demand rather than a storage configuration, looking at alternative fuels. Fuel cells are really something that we want to ensure that we're using. And really, the last one is that critical infrastructure technology, on mechanical systems and battery systems, of evolving that and moving that forward. So that's definitely all the things that we're looking forward to. And I thank you. And I think now I'm passing it on to Sam.
That's right. Let me pass that screen control for Sam's purpose. Sam, you can come forward and I'll bring your slides up.
Brilliant. Thank you, Derek.
Don't forget to introduce yourself, and you're getting screen control now. Take it away.
Brilliant. Thank you. Let me see if it works, first of all. Yes, it does. Hi, everyone. And by the way, first of all, thanks, Chris, Mike, Ryan, and Todd. And it's Sam Collis speaking here from Liberty Global. I head the corporate responsibility and sustainability agenda for us at Liberty on a group level. And may I just say, I think that was a really exciting set of presentations. And I'm afraid for the audience, you will see a little bit of similar, in some cases, what you see, but maybe with a different angle. And of course, I think there is a reason for that. Of course, and the reason is because energy is really important, and sustainability, I think, and I hope you all agree, is extremely important. And I think there's a lot of evidence, certainly in the last 2 years, that also is an evidence of why our industry is so important. So let's dig into it. So maybe putting that a little bit in writing, everything what you saw actually up to now, I think, is something that we benefit from, not only on the environmental perspective and operational and savings, but there are also some reputational dimension to that as well. I think we all agree that nowadays, certainly younger generation and customers and non-customers and the communities we serve do really see what we do as being extremely important in taking our responsibilities. So beyond the operational saving, which I'm not going to go into in detail, obviously that the connection and that engagement with our employees is also a very important one, because we are able to scale, certainly in a Liberty's case, across the group from one team to the other. And what that really helps us to do is to really bring those great ideas and implement them where you may want to benefit from one and focus on the next innovation. So that really helps our industry to innovate a lot. That's certainly true in the case of Liberty Global. But as you all know, for the entire MSO group, that's why we're all sitting here together. And then what I actually wanted to do as well today is to see what have we actually done so far. So I did a bit of a deep dive, a bit more on the energy program itself. And basically, in a sense, when we look at what we can do around that space, purely around energy, it's basically an energy heat map. You can divide that into 3 different dimensions. You have the price dimension, a volume dimension, and a time dimension. And what you see on the screen is an example of a study that we did by going across the Liberty Global countries and operations and identifying the benefits, obviously the challenges, but also more importantly, the opportunities that we have in that space in each of the areas, and putting that and aggregating it all together. We actually came up with a 16% benefit across basically all dimensions. So a very short deep dive into each one of them. When you look at the energy heat map and the volume dimension, there are quite a few themes you can look at, but essentially 3 of them are probably the most important. One of them is the consumption management of that. The other one is obviously the smart building management, so the operation, so making sure that you really have smart buildings. And the third theme is the investments that you make in that area. And what we found out is a number of challenges that we would need to deal with. And probably the most important one is you can make quite some leeway in terms of cooling improvements. But if there's a lot already implemented and you don't have the right controls, that normally does cause some challenges that you need to solve as well. But that in itself is also an opportunity, because it gives you basically the opening to make the right investments to implement those type of controls and systems, so that you can optimize more and more. And on top of that, of course, we didn't talk much about that today, but as Derek would probably tell you many times over and over again, the program is also about making sure there is network reliability. And when you have those smart controls, you do increase the network reliability as well. And then the next dimension, so the time dimension, a number of themes there. Obviously there is a clear responsibility with our procurement teams, which they obviously do a great job in already. And there's a lot more to be done there, of course, but there is, also PPAs and on-site generations that you can utilize within the time dimension. There is obviously a bill validation theme in that, but also potentially tax and incentives, obviously depending on in which region you operate. Just to give maybe a couple of challenges there that we at least came across is that, you may not always have those, for example, tax incentives everywhere. There's obviously still important that you implement some of those, because you do benefit from that. And the potential of that, of course, is, for example, when you have a bill validation on a regular basis, there will potentially be quite some waste spend that you can manage, and you manage that not at the end of the year, potentially, if you do that every day or every week, you can manage that before months' bills and invoices. And then I don't obviously go into deep dive into all of those, just to give you a bit of an idea of the dimensions, of course. Yeah, the last dimension is the price dimension. And within the price dimension, obviously there is a number of themes, but I would say probably the most important one is that whether the region you're in, there is a potential for a daily management, basically demand management, of course, if there is a triad management. And I know that in some countries, certainly in Europe, this is very common. In some countries, this is less common, but potentially you have an opportunity to tap into that type of demand, and that has a price benefit for you as a business, but it has even a greater price benefit and even a greater environmental benefit that goes beyond your business, of course. But when you manage that demand for an entire, and of course in cooperation with many others, you manage that for an entire power plant that would not need to be basically fired up, as a result of that, you save many million tons probably of CO2 equivalent emissions. So there is, always important to look at the entire, all 3 dimensions actually in a environmental way as well, or sustainability way as well. And then maybe just to do a bit of a refresher on, Energy 2020, we've done so many different initiatives across that, group you've been hearing from over the past 5-6 years. I think it would be a pity not to, highlight some of those, of course, yeah. And we'll do a bit of a deep dive on the temperature rise, raising temperature set points, of course, yeah. But, repeating a little bit of maybe what Ryan and obviously everyone else here mentioned as well, quite often when we look at replacing all the equipment, certainly PSUs, so power supply units and rectifiers, in our case, in the examples we had, you basically can shift from a 35% OPEX loss, which I would call, actually wasted energy OPEX, down to 6. So going from an 86 UPS efficiency to a 96, you can imagine if you do that over multiple sites, just the amount of savings that you can make there. And then, utilizing the natural environment for cooling your sites, using free air in the combination or without the combination of PCM, again, you can have massive savings there. We have examples of going to a PUE of 1.05 in some cases, which is, almost unheard of, right? But that's for free. That comes from the free air. And then some examples, maybe an example about the outside plant, and that's a really got a social aspect to it. During the hurricane in Puerto Rico, we had just prior to that, a year before, we had done an exercise of centralizing some nodes together with the Alpha and Coppervale team, as you probably will all know them, thanks to their great work. Of course, within the pilot, you could see after the hurricane, these were some of the very few sites that had continuous power. So again, the reliability of the network is improved massively too. And then of course, airflow management. We've seen over the years the number of not only OPEX savings, but a lot of energy savings by just making sure you have the right airflow management for the sites. And there is a paper that we did publish at the 2016 Expo, which is called the Oreo paper. And the team actually did a presentation on that on site at the time. So please go and read it. I mean, if you want to read a little bit more about that and understand, you will see the benefits of airflow management. It could be very simple in some cases even. And then of course, on-site generations, no need to go into that, but there's a huge potential in tapping into new technologies that are being developed, whether it's fuel cells on different fuels, whether it's on-site renewable, as in, solar cells, wind, etc. So let's maybe just deep dive a little bit into the raising temperature set points, because I think that's a absolutely great opportunity that we're going to be doing more and more of that and encouraging everyone to think about. And that is, we did some pilots. This is a pilot example, and we have more examples of that. But that pilot example was raising basically temperature set points from 19 to 23 in 4 different phases. The amazing thing was during the pilot, of course, after installing just the right monitoring and controls, we saw that for every Celsius degree that you raise the temperatures, and of course, don't forget that equipment is becoming more resilient. So we are able to do this. We saw a 6% saving in terms of energy. And of course, that is to a certain peak. After that, you don't achieve 6%. But you imagine if you did that to the point where you just peak it out, for every Celsius degree, that's a lot of savings that you can have. And what you see on here is an example site, which is a smaller site, but we obviously did that on a number of different locations. And in 2020 alone, just on that exercise, the savings were 1 gigawatt hours for just a small handful of technical sites. So there's a lot to be done in that space. And I think we have obviously still a lot more to share among the group here, but also within each of our groups. And of course, for the great works that our engineers, ourselves, and of course, not least, I would say the big names in this audience is obviously our technology partners, of course, that help us to achieve a lot of this. And I think looking forward to, just like everyone else, for the next few years to come in this program and using all these great standards that we develop, all of us here together. And now back to you, Derek.
Thank you, Sam. And I do want to thank all of our key cable operator partners here who presented. It's my honor and privilege to work with them day in and day out to help shape the industry's future, impact the past of energy performance and really raise the bar on making energy a priority from both a reliability and a sustainability approach. So again, thank you all for your time and your presentations. You can carry on the conversation on the general chat, but it's time now to move into our Gridmetrics team. So I want to give a round of applause to you guys as we transition to the gallery view for our team today. So Dr. Bob and Steve and John, welcome to the stage.
Thanks, Derek.
As the gallery view is coming up for us, Why don't we start with a brief introduction so people know who you are and I can facilitate that. So Dr. Bob, who are you? What do you do? And then brief intro of who you are.
Thanks, Derek. So I'm a 27-year cable veteran, led the development of the DOCSIS 1.x modem at Cable Labs, had my eye on building a network so we could do energy management with all these modems. I've been kind of staying on that course for the last 30 years or so. And working now with the Gridmetrics team. I spent the last 5 years research and development in electric grid applications. I was at the National Renewable Energy Laboratory finishing my PhD, and it was there when working with colleagues that came up with this idea for Gridmetrics, where we could use the cable network to monitor the grid. The more we talked about it, the more it made sense. And we shared the idea with, brought the idea to Cable Labs, and the rest has just really taken off. And so very excited about what we're able to do, what we're able to see. We actually have an unrivaled view of the grid. And as many of you know, the grid's, got increased outages, and we'll talk more about that in our talk. And thanks for having me here.
Thank you, Dr. Bob. And how about John? You can go next.
Thanks, Derek. I'm John Peterson, Chief Technology Innovation Officer for Midco. I've been in the industry and with Midco now for 36 years. And my focus has always been what's next? What's the new technology? And that certainly hasn't changed. And a few years ago, I was pitched the Gridmetrics story, and it just, smelled right. And it seemed like a really great thing to do on multiple fronts. So part of the reason that I'm in this panel is because I can represent, an MSO view. And we were an early, but the first supporter of Gridmetrics and an ardent supporter all along. And so looking forward to a lively discussion.
Thank you, John. And last but certainly not least, Steve.
Hi, I'm Steve Glennon. I'm a distinguished technologist at Cable Labs. I work in the Advanced Technology Group. And I kind of got co-opted into this whole activity as Dr. Bob kind of took us from the path of simple monitoring of power supplies through SNMP to a concept. I was collared in the hallway by Scott Caruso to say, hey, these guys are telling me you could build a really inexpensive sensor that would basically give you oscilloscope level visibility into what's happening on the power grid. And it would cost not a whole lot of money. I mean, would that be possible? And my response was, yeah, it's really not that difficult to do. So Caruso then kind of said, so would you? I'm like, okay, as long as you don't tell my boss. So I've spent the last about a year and a half working on developing low-cost sensors that we could actually put out in the plant and give us the equivalent of visibility of a technician sitting at every power supply with an oscilloscope, taking a look at what's going on and being able to say, hey, something doesn't look right. We should take a look at that. So that kind of visibility is what we're trying to achieve.
Great for that. Thank you for that intro, Steve, for both yourself and what Gridmetrics is in essence, because that was part of my first question to you guys was like, what is this Gridmetrics thing? So you kind of touched on that as a network of sensors, but part two of that intro question and maybe, Dr. Bob, I remember having the conversation with you in the Green Pavilion a few years ago as the energy program was really ramping up. But, why are we even looking at Gridmetrics in the first place? What's the point of this? Why are we doing this?
Well, there's a lot of good reasons, and I'm sure everybody's going to pitch in on this, with answers. But I think we start out with the things that we know, right? The cost of energy is going up, right? The dollars per kilowatt hour is only going up. It's doubled in the last 20 years. The cost the money that we're putting into standby power systems is going up constantly. Every time we have an outage, it costs us. And we build more standby power systems, have more guys running around with generators, et cetera. And outages have gone up 8 times or so in the last 20 years. So a lot of this is really around, just positioning so that we've got reliable power that is cost effective for us so that we can keep the customer experience, in a good place. And then, when you think about where these outages are actually coming from, severe weather is acting like a battering ram on the grid, and it's also changing the demand. In Texas, we saw unprecedented demand in the wintertime, which was a head scratcher. And then in the Northwest, we saw unprecedented demand in the summertime, which was a head scratcher. And, the grid wasn't even built to provide that kind of demand in those places. So we've got the grid kind of on the ropes a little bit. It's many parts of it are over 100 years old. And so we've got these failures that, affect us, certainly affect us financially. And all we can do to contain that is going to be good. And there's probably no other white knight on the horizon that's anything like us in terms of having the instrumentation, which we'll talk about, and then the backhaul. The grid is about 6 million miles and it's sensor starved. They just don't have the sensors and they don't have the backhaul. So we're in a really great position, like we did with digital TV and like we did with internet and like we did with phone. We've got the technology right now for an industry that's really shaking and on the ropes, and we can do a lot to help them.
Great, thank you, John. You, as an operator, you get both the insights of the power supplies themselves, and you're also a customer of the grid. So, what are your thoughts?
Yeah, I think like a lot of cable companies, we use a very common power supply throughout our plant, and we monitor it, and we pull that back to our centralized NOC. And it was funny because I had commented, guys, it's like we're the NOC for the power company because we're always the first one to call. And as I got into it a little more with, getting into Gridmetrics, it's absolutely shocking how primitive the power grid is. They only monitor down to the power of the substation, and they just have no ability unless somebody calls in. And overlaying in parallel to this network is this thing we call the cable network. And so, practically every kilometer we have an Ethernet connection and a power monitor. That's already there, already working, already reporting. It's like, what's not to like about this? There's some opportunity here. And so that's kind of how we got involved and why I think Gridmetrics exists.
That's great. And Steve, from a technical standpoint, I know you've done a lot of work with the initial sensors. What's your insight into, is it as simple as flipping a switch and now we have this magical Gridmetrics thing?
It's pretty simple. I think the key thing here is taking us from kind of the power grid being a one-way. You got generation, transmission, distribution, and the basic expectation is, it's a terrible paradigm to a physicist, but the electrons flow one way. That's not really quite how it is, but it's kind of like a downhill distribution. And as we start to get into more sophisticated environments where home solar generation is starting to take place, you've now actually got a whole bunch of things where the grid is becoming more two-way. There's power being put into it and sent downstream, but there's also been power put in from the individual households. And that kind of generates some problems in terms of visibility for the electric utility as to what's happening, how many of those are generating really good in-phase clean power into the network, and how many are generating noise and other junk that's actually degrading the quality of the electric grid. And the Gridmetrics 1.0 is our ability to go aggregate and monitor just the voltage levels of what's happening in the power supplies. But now we take the step forward where we can actually start to get real visibility into what exactly is happening to the waveform on a sample by sample basis to understand when we're starting to see things which the electric utility needs to start taking care of to understand, diagnose before it becomes a reliability and robustness issue for generation. Now, a beautiful side effect of that is once we have that ability, once we put an inexpensive sensor into the power supply cabinet, it's really non-intrusive. You do the install, put it there. You now have visibility not only into the grid itself, but visibility into the state of power on the coax. So you can actually monitor the waveform itself. You can detect problems like loose faceplates that are causing shorts. You can see glitches on the consumption. You really start to see what's going on in the network and really start to take proactive measures to go find and fix those issues rather than just dealing with random outages in the network that people don't quite understand. A node rebooted and we don't know why. It could be a loose faceplate, but until you start to get that visibility, you don't really understand what's taking place. And I think specifically to your point about how hard is it, we're trying to make this completely modular as a retrofit. You just throw the sensor into the cabinet, plug into existing connectors in the cabinet, and walk away. And at that point, it's starting to report back to central aggregation that tells you what's going on.
It's great to have all those cable modems sitting out there as polling devices. So awesome. Looking into the next question, what's the opportunity for us as an industry, as the broadband industry, to play in modernization of the grid? I know the DOE's been looking at, smart grid and initiatives around that. Some even ANSI itself had done some research that we were involved with in the earlier days, around like 2009, give or take. So what's our opportunity, and maybe John, as an operator, what's your point of view from both the customer of Gridmetrics and an enabler of the technology?
Yeah, I'll start with that. First off, I want to reiterate that the lift on this is almost non-existent, right? I mean, the biggest issue that we had was, that one problematic sensor that was out there. I guess we can't let that rest for so long, right? We're going to have to go and fix that. But we're not really doing anything we weren't doing already. We're just we're just putting it into the Gridmetrics aggregator. So for us, in terms of lift versus payback, when lift is pretty much zero, the payback can be whatever it needs to be, and so there is a revenue share model, and it's not hugely significant, but you do get some money back as people use the data. But for us, I think the biggest benefit is being a force for good, right? And that's something that we always want to do. We want to participate in the communities and improve them. And we want to be able to say that we are, right? And this is a way for us to just say, this is something we're involved in. It's big, and we're in this together with many other cable operators. And it's nationwide, and it really fixes a problem. And it's not just a problem that the utilities have, but all of the other folks that rely on that, insurance companies, et cetera, and Dr. Bob can talk about those. But honestly, it's an easy way for us as a cable company to do a lot of good.
Awesome. And Dr. Bob, do you want to add to that any additional comments around, what's our benefit? What's your point of view?
I think the opportunities and the benefits, if you just even start looking at outages, the ability, as John was saying, to even coordinate outages or detect outages or even predict outages, that has enormous impacts on our safety, whether it's the safety of our guys or the safety of emergency responders that have to go in there, or, as John was saying, other industries that work in the verticals, insurance and others. Everybody wants to know if the grid's okay. And what the status of the grid is. And the closest technology to what we're doing isn't close at all. It's really screen scraping websites of 3,200 different utilities. And so when you think about what it's like, as many of us have built screen scraping applications, the webmaster at a utility changes their something on their webpage, and now all of a sudden that screen scraping doesn't work. So with 3,200 utilities just in the United States, to have to go to, in a machine-to-machine communication versus going to one IP address where you can get the status of the grid, for anywhere in the US now, but ultimately anywhere in the world. There's scale that we bring that just no other industry has because of these power supplies, as John and Steve were saying. They're already out there, right? There's already a couple of million power supplies around the world. They're already being monitored at the local level because the local guys in the systems need to know if there's an outage to declare. And in Gridmetrics 1, it was really just bring all that data that's already being collected back to a single IP address, and then start making derivative products from it. So lots of opportunities. We've already got this power event notification system that we've built on top of the data, and anybody can at gridmetrics.io, which is our website, gridmetrics.io, you can sign up and get alerts in your area, and people become very surprised at how much there are outages. We don't see it that much in our homes, but that's a scale thing. When you start looking broadly enough, you realize how many failures there are. As I said before, it's up by a factor of 8 in the last 20 years. And of course, with severe weather, we're seeing things fail that never failed before, like the tower that fell over in New Orleans. So I think the biggest opportunity is really around helping us get a handle on outages and minimizing outages, minimizing their impacts, minimizing the safety impacts, et cetera.
And Dr. Bob, one of the questions on chat that you kind of touched on, and I think it's a combination of what's leading to this 8-year rise of outage. Is it really the the global warming, the climate change? Is it the aging infrastructure? Is it a perfect, no pun intended, perfect storm of both? What's your insight onto why that's gone up?
We'll actually, I've got a slide on that we'll be presenting tomorrow at our session. Yeah, about 40% of the outages in 2020 were due to severe weather.
Okay.
And of course, we don't have a handle. We're not driving the bus on that. So, the best we can do is use our system to really figure out where the grid's going to fail next, and then coordinate closely with our utility partners in a really automated way to expedite the repair and even catch things before they fail.
So it really is an amazing bit of innovation with big data. Cable Labs is really big on data and collecting data. I know Debbie Fitzgerald, who's presented a number of times as part of the voluntary agreement, is I've got a lot of hands on data and insight into that. So this is another platform that really enables us as an industry to have this single pane of glass into how the grid is operating. And that's been a conundrum for the DOE for a long time. So I hope, people that are in the energy industry gets a hold of the recording here and can reach out to us to get, how to get involved. And speaking of getting involved, I know Steve, clearly John's with Midco, but is there opportunity for other operators to sign up to, contribute data to the platform?
Absolutely. We've got a pretty good sort of coverage across the US, and we're looking to expand that. It's kind of the network effect of the more that you aggregate, the more that there is global benefit to participation. So we'd urge members, even though there may not be a significant financial payback to them initially, that really starting to participate in this gives a great opportunity to build the kind of the network effect here. I think right now we're at about 300,000 power supplies in North America are monitored and part of this aggregation. And we'd really like to make sure that we get every cable power supply that's out there to be a part of that activity. Right now our focus is North America, but we really want to kind of extend this out to a global presence to give the kind of insights and benefits that bring real good. I mean, to John's point earlier about doing good, seeing a number of the activities that the existing product have given visibility into, like the snowstorm in Houston and various hurricanes and things going through New Orleans, you get direct visibility and feedback to entities like FEMA and local governments to be able to go and see what's happened where do they need to go deal with truly emergent problems like a hospital or a care facility that's lost power in the heat of summer, that they can really focus their activities around where there's a problem and bring real good real human good to this whole activity. It's not just an abstract picture of like, hey, it's interesting to monitor the power. There's real human good that can be done from the insights that you gain here.
And Derek, if I could just add, for those that might be skeptical, this is not just getting started, right? There's 150 million people live within a kilometer of a Gridmetrics power supply. It's about 45% of the US. So this is a real deal, and the more the merrier.
That's great. And a follow-on question, and maybe all of you just putting it out there, there's a lot of tools in the 10G reliability toolkit, but this feels like, would you agree? How vital is this to improving the 10G reliability, cornerstone?
I think it's critical. We start to talk about, we see outages, random outages that we can't really understand what happened, and gaining forensic insights as to what's going on to be able to actually improve the plant is critical to this. And a lot of that is, shaky connections, power, disturbances that cause outages, and gaining that visibility to be able to understand where it has an impact on the networks and what we can do to make it more robust, I think is critical to kind of moving to the next number of nines in terms of reliability.
That's great, especially with the injection of renewables that may be variable in production and distributed energy resources. I could see this playing an important and critical role in quality of power measurement, because some of the electronic stuff in our plants and critical facilities are very sensitive to power fluctuation and quality. So that's great news. So
there's a question that came up in chat about you should sell these insights to the electric utilities, and that's completely on point. As we move from Gridmetrics 1, which is really kind of outage territory, as we move into Gridmetrics 2, where we have sensors that are basically oscilloscopes we can literally provide insights to what's going on a waveform basis to the power utilities. And we're already seeing significant interest from power utilities getting to pilot deployments of these second generation sensors, so that we can provide them with those insights and they can actually get real monitoring capability as to what's happening on the grid that they just don't have right now, and that they are literally years away from being able to deploy themselves.
That's awesome. Follow on question, John. I'm wondering, what's involved for either an operator like yourself to get involved and sign up for Gridmetrics? Is there, a lot of training? How do you just get your foot in the door?
Well, the first step would be just to contact someone at Gridmetrics. I would be happy to facilitate that, but it's more of just finding out what it's about, what it will take. And if you're already monitoring your plant, the lift is, again, very light, and it's just a matter of getting hooked up with Gridmetrics to have your data sent there. And it took us a little while to get that going, but we were the first ones, and after that's all done now, right? So all of that's pretty well established. And if you've got the data, seriously, it's probably about a 2-week process. Somebody's going to kill me for saying that, but it's just not that involved, right? It's here's the data, we're going to send it this way in addition to our NOC. And so, yeah, it's contact someone at Gridmetrics. Like I said, I'd be happy to facilitate that. It's not that big a deal.
I think we might know somebody, and I got to point the right way, Steve.
Yeah, I'm happy to help.
You may be able to lend a hand there.
Yeah.
So let's see, are there any other questions from our audience? Because we do have the chat running. We've covered a number with the climate and the impact of the outage. We have a comment about the working with the utility and selling the data. Is there any, looking at the evolution of Gridmetrics, what do you think the end game, the prize, the eye in the prize, where do you think the possibilities are with this? And I'll just open that up to any of you. Who wants to take that first?
I'll pitch in, never shy. I think that the key thing here is we talk about smart grids and what does smart grid mean? I think smart grid is about having visibility and being able to respond to what you find. And I think this is really the single largest holistic opportunity to gain visibility at a national scale of what's happening in the electric grid. And I think that has huge value, not just to disaster response, but also to cybersecurity. There's a great video that talks about how 7 lines of code were able to destroy a 70-ton generator. You should go take a look for this. There's basically the situation is when the generator is cranking up, there's a contactor switch that when the generator is synchronized with the power grid, phase synchronized, the breaker switches and connects it to the grid. And the 7 lines of code were to basically say, instead of waiting till it's in phase, we're going to switch it when it's completely out of phase. So now you've got a 70-ton generator that is fighting the electric grid. And a 70-ton generator jumps off the ground when that happens. So there's this huge cybersecurity threat. It's not just like, oh, someone flipped a breaker somewhere and an engineer's got to go out there and flip it back. There's real destructive long-term possibilities around damage to the electric grid. Having that visibility, having the detailed visibility, gives you the ability to detect and respond to cyber threats around the electric distribution network. So that's critical. I mean, my solar inverter, I've got a 9 kilowatt system at home. My solar inverter is connected to the web via a cellular modem. And all it's going to take is for some miscreant to go out there and work out, hey, I wonder if I can get that thing to go anti-phase with the power grid and what will happen then. So that you can detect that kind of activity of people meddling with the things attached to the supply, and you can start to detect and respond to that. So I think there's some real, there's an opportunity for the cable industry to become the dominant player in the smart grid, to provide the visibility that all our utilities and our governments need into what's happening in the grid. And I think we're in the catbird seat to actually be that entity. So I think it's a huge deal for us.
Great overview. That was awesome. I couldn't agree more with the cybersecurity added benefit is just so huge. Let's see, we got one more coming in, unless there's any other comment around the eye and the price, Dr. Bob or John Norman.
Yeah, I'd love to pile on there a little bit. Absolutely love the cybersecurity application. And it's the first, I ended up writing 5 different proposals to the US Department of Energy for funding. And it wasn't until I wrote a cybersecurity one, which was number 5. I had gotten turned down on all 4, and they bit on the 5th one, and then they bit on the 6th one. So we've got 2 cybersecurity projects. We're just finishing up the second year of one, and it provides non-member funding to cable labs to do this work. So really good. And Steve, you make all the right points in terms of the way that people can get into an unsecured network. It's just everywhere. And so when you take the expertise that we've developed in the cable industry as network guys over the last 30 years, putting on the cable hat, it's really easy to say we've seen this movie before. Right? They're going from one way to 2-way with content creation at the edge, right? As PV starts putting electricity back into the network. Their customers have to call to declare an outage. Remember the question that we even is very poignant today is how many modems can I put in this neighborhood before the grids, before the network slows down? All right. And I started mixing the words already because their question, which we can help them with on the utility side, is how many electric vehicles can I put off of this transformer before it's going to overheat and have a premature failure of life? And so you start thinking about how all that we've learned in traffic engineering and capacity planning, and in cybersecurity, as Steve said, these are all directly applicable to this big network that we just ride right alongside of, that we need to run reliably so that we can provide our business. So, we have a self-interest, but to everybody's point, we can do so much good by keeping this thing up and keeping it running reliably. And then the one last point I'll share, and we'll talk about it some more in the session tomorrow with Frank Sandoval. If you think about where we were in the late 1970s, you couldn't buy a phone, right? Your phone came from the phone company, and the only phones that you got were from the phone company. And then we got into this situation where long distance calls were cheaper after 5 o'clock. And why were they cheaper after 5 o'clock? Because they were trying to shape the load on their network. They were trying to, discourage calls during peak and move them to off peak so that they didn't have to build new facilities that were only going to be used for a few hours a year on Mother's Day, right? Which is the biggest call time of the year. These lessons from the 70s directly apply, and what we've learned, of course, in the last few decades, directly apply to right now, because the grid has all these resources in generation that are only used at peak, some for only a handful of hours a year. And to have that kind of situation where you could actually manage the load on the grid, and you could have loads be responsive to the availability of renewables, you can start bringing the costs down on the grid tremendously, which is, of course, going to affect our bottom line.
I would just add that, I'd like to look into the future, and I'm kind of a science fiction guy, and you kind of say, I wonder when that smart grid thing is going to happen, and who's going to build that. And it's, and I have to sit back and say, yeah, I know, I can tell you, right? I mean, this could be the genesis of that smart grid that we've all been talking about for 10 years. And why can't it be us?
They've been hunting for it, and we built, as the slogan says for the Energy 2020, we built the standards today, and we're enabling that vision of tomorrow, not only for us, but really for now the power industry. So it's an amazing, journey that the team's been on for the last, I'd say, what is it, 3 years now, since from inception, conception, ideation, all the way through to realization and execution. So, phenomenal work to the team here. We're running a little bit tight on time. We got about 7 minutes left. I did get one more question from the audience, but I want to raise that. So Chris asks, for HVAC systems, has there been any discussion for waste heat utilization forward as energy reaches the net zero energy? It's not exactly a Gridmetrics question, but is anybody that you guys know of looking at waste heat recapture?
The waste heat is incredible. And we certainly saw the description in Ryan's presentation earlier today, saying that, 3/4 of Comcast NBC Universal's greenhouse gas emissions come from the electricity they purchase. Which is just a shocking statistic. And most people don't realize that when they burn fuel, coal, oil, natural gas, to make electricity, 1/3 of the energy goes into the wires and 2/3 goes off as waste heat. So the heat rejection is unbelievable, as well as the greenhouse gas rejection. So the more we can do to tame systems that pump out this kind of heat, the better. And I think that in the data center space, the most effective thing we can do, Sam Cola's folks at Liberty had pioneered this and done a white paper on it. And then we had a paper in the SCTE Technical Journal a little bit ago, this idea of using phase change materials in the data centers and hub sites where they can store the cooling that's available from free cooling or from compressors that are able to run longer and have higher efficiencies. All of those, contribute to our bottom line and reduce the heat emissions out into the environment.
Certainly an opportunity for capture. I know it's there. We've done, like you said, some studies. So thanks for that insight, and thanks for getting to Chris's question. Well, with 6 minutes left, I want to give opportunity. Steve, John, and Dr. Bob, any final questions, any final statements regarding Gridmetrics, where we're headed and what's going on? I know the last bit of information right before the audience question was right on point, but let's bring it home. What do you have to wind up with?
I think a key thing here is this is standards based. We're not trying to do some proprietary end run. So I think Dr. Bob heavily involved in SCTE 271, which is defining the parameters of waveform monitoring of the power network. The work we're doing within Cable Labs is to create a standardized protocol for talking to the sensors. We're not really in the sensor business. We're making a couple of hundred sensors to do pilots and to prove the value of this, prove the viability, the reliability, and the value of the insights that you can achieve. But our expectation here, we have a spec we calling the raw data transport protocol, which is how do you get data from the sensor to the central aggregation point, so that we can end up with standards-based aggregation of data in this space. So it's all about using our standards bodies to be able to get these insights effectively in the power grid.
Thank you. Speaking my language, John.
I would just say that this is our opportunity to digitally transform the power grid, and we would kick ourselves if we didn't jump all over it.
All the tools are right at our fingertips. Leverage them, use them, enable them. And Dr. Bob, last words of wisdom before we transition to wind down.
Thank you. It's really been great being with everybody today, and I think we covered all the high spots. Just in recap, we created 2 new standards this year, and one, as Steve said, SCTE 271, was really inspired by the success we were seeing in Gridmetrics. And we turned to each other and said, well, if everybody likes the data so far, and we designed those sensors in the late 1990s, what would we design today that could take advantage of our backhaul? And this idea of 1 millisecond latency that no one's going to touch with low latency DOCSIS. So kind of what would we design today? So that was really the spirit behind SCTE 271. And we brought in the national laboratories and vendors and got a lot of people in the cable industry that hadn't been in the cable industry, connecting NREL with Cable Labs and others. So that's just a phenomenal now, if you will, sort of an MRI or X-ray system, right? That Steve has built the first couple of hundred modems and prototypes. We can see the grid really in an unrivaled way that no matter how much money the utilities throw at it, they're not going to be able to catch or match what we're doing, simply because of all the work in DOCSIS that came before that supports all of this, and the networks we've done, and the fiber into the neighborhoods. So that's SCTE 271, and then SCTE 267 in optimum load shaping. That goes back to the phone calls are cheaper after 5 o'clock on the phone network. And it goes right into all the capacity planning and traffic engineering we've done over the decades to make sure people don't have slowdowns, and our network works in the pandemic, right? Which we've heard so much today, how we took a whole year's worth of load and it happened instantly, and we've handled it. The grid needs that as well, and with our standards, we're ready to provide it. So I think this orchestration, if you will, of supply and demand and managing content at the edge is going to be really great.
No, thank you for those closing words and plugs for the SCTE ANSI accredited standards development team. I guess the key takeaway is the door is open. Come on down if you have an idea for standardization. We're open to those ideas. Like you said, we worked with the DOE, we worked with NREL, we worked with the other labs. That was a first for us. Thanks for bringing them to the table. And I want to thank all of you panelists here with the Gridmetrics team, my earlier discussion with the MSOs, It's truly been an exciting 90 minutes. It's flown by as it always has. I wish we were in person. You know, I really feel that next year will be that year. We're going to be in Philly. We will be in person. We'll be able to shake hands safely and spend some really great time together. I did appreciate all of you taking time out of your busy afternoon to learn about the Energy 2020 program with SCTE and Cable Labs. So mark your calendars. Energy 2020's next in-person meeting, fingers crossed, will be hosted April 6th and 7th of 2022. I love that. It has a ring to it. You know, I'm a numbers guy, and 3 2s, it feels right. So we're going to hit it. Cable Labs will be our host out in Colorado. Mark your calendar. So with that, I want to close down on time because here on the East Coast, it's dinner time. Sam, you get the award. I think it's almost midnight where you are. So hats off to you for hanging in there so long. So with that, I want to say thank you very much. Be safe, be well, and we'll see you tomorrow for our next session. Thank you, everybody.